Greetings everybody. My name is Enveri Sufi. I work in Institute for Organic Agriculture in Albania. I am expert in plant protection and organic agriculture. The title of presentation for today is Grape Moth Lobesia botrana Control in Organic Grape Production with Metting Disruption Pheromones. In the white plant, there are present many insect pests. In different climatic zones, in different countries, in different continents, we find all the insect pests that are described in literature. But what is different between the countries is different infection level of insect pests and different species. In different countries, the status of insect pests is quite different. On the other hand, the situation of insect pests is always in change from time to time. Why situation of insect pests is so different from zone to zone, from country to country, and from time to time? This is so for some reasons. Different climatic conditions, different grape cultivars, different agricultural practices applied in vineyard, different situation of beneficial insects, different agriculture systems. Each part of the grape plant has its insect pest. In the grape are found insect pests in the roots, in the trunk, shoots, buds, leaves, and berries. Estimation of insect pests in vineyard according to economic importance. In this sense, insect pests on the grape, from economic point of view, we could divide insect pests with big economic importance, or so-called key pests, secondary pests, that means they are not every year with economic importance, and insects that appears rarely, perhaps one time within 10 years or more. In the grape, we could find the moths, scales, mite, beetle insects, cicada, etc. Almost all vineyards everywhere in the world, as the key insect pest is grape moth Lobesia botrana. Why Lobesia botrana is a key insect pest in a vineyard? Because it appears every year more or less in the same intensity. Developed 3 generations per season, make direct and indirect economic damage, need an intensive monitoring in order to take the control measure in the right time, need a knowledge in managing phenomenon of resistance of grape moth to different plant protection products. Control measures with insecticide have a negative impact to environment too. Here we see some different thrip species could be found in vineyard. Some spider mite species on the grape. The first is Tetranicus urtice. The second is Pananicus ulmi. We see here the eggs on the branches, and we see the adult. The next picture is the symptoms, a bronze color of the leaves. And another one is Eriophis vitis. That means the spider mite, different species are. Some scale species on the grape. Different species of cicada in the vineyard. Some species are virus diseases vectors too. Some coleoptera, some beetles, insect on the grape, Anomalevitis, Otorhynchus sulcatus, and we see here the larvae and the adults. Phylloxera on the grape. We see here the leaf form and the roots form. Now we'll speak more in detail about the grape moth Lobesia botrana as a key pest in grape, and we speak about control measure in organic vineyards. This is a biological cycle of Lobesia botrana. Lobesia botrana overwintering is a pupe. From the pupe in the beginning of the April, hatch the adults. After mating of the adults, the females lay the eggs on the berries or the fluorescence and the berries, and from the eggs hatched again the larvae. Lobesia botrana developed 3 generations per year. The first generation is not so dangerous because the larvae eat the fluorescence, has so many flowers that make not a big damage. The second and third generation is very dangerous, not only for direct damage, but for indirect damage. We see here the stages of Lobesia botrana. The first is the moth. The second picture are the berries, eggs on the berries, small one. The picture 3 is a fresh eggs enlarged. The 4 picture eggs before the hatching, we see inside the eggs the larvae. The picture 5, infected fluorescence of first generation. Then the infection of second generation, an infection of third generation, and the pupe in the winter time. There are the stages of Lobesia botrana. On the description of the stages of Lobesia botrana. Moth, the adult, with a length about 6 to 8 millimeters, with wingspan about 11 to 13 millimeters. The size of moth depends from feeding quality. Adult or female are slightly longer than male adults. Egg. Fresh egg has a white color, and after some days, in yellow in cream color. Round in the shape, and before the hatching is a gray color. Has a size 0.65 to 0.19 millimeters long and 0.45 to 0.75 width. The larvae reach the length from 8 to 10 millimeters. Fully grown larva has a size 10 to 50 millimeters with a yellowish green to light brown. The head of the larva is yellow color. There are yellowish green to light brown. The head has a light yellow color. Pupe has a size 4.5 to 6.75 millimeter. Pupe has brown color. The pupe of the male is something longer than the pupe that hatched the female adults. Lobesia botrana overwintering is a pupe stage. In the pictures, we see the indirect damage of Lobesia botrana. Damaged berries stimulate the gray mold Botrytis cinerea. The holes on the berries opened from the larvae are enter points for Botrytis spores. In Mediterranean conditions, Lobesia botrana developed 3 generations per year. The first moth from the pupa of overwintering hatched in the first decade of April. In general, for a first generation are not make the chemical treatments because the larvae consume the unnecessary flowers. The second treatment normally are made at the end of June, beginning of July. The treatments from third generation are made during the end of July to the first period of the August. For the third generation could be made 2 treatments because the flowering time of adult continue for many days. Monitoring by pheromones have demonstrated that climate change has prolonged flight period until the end of November. This is an observation in alpine conditions. Monitoring of Lobesia botrana. Monitoring of Lobesia botrana is focused in flying curve and in monitoring of infection of berries from the larvae. Monitoring is made with pheromones. Monitoring flight dynamics help very much for right disease and for control measures. The disease and from treatments depends from feature of plant production products, from climatic conditions, from grape cultivars, and according to the agriculture system. In organic agriculture, vineyards must be used only allowed plant protection products. That means only with products that are in the positive list of inputs. As a criterion for beginning of treatments could be beginning of flying or maximum of flying, or when the first new eggs are detected, or the first larvae are detected. Economic threshold for grape moth is 10 larvae for 100 cluster branches or grape. In the case of grape for destination from wine. For grape for fresh consume, threshold is smaller. It's about 2 larvae in 100 cluster or 100 benches of the grape. Monitoring of grape moth Lobesia botrana with pheromones. Adults of Lobesia botrana in sticky paper, and we see here the rubber dispenser. Dispenser has absorbed the pheromone substances. The pheromone substances attract the adult of Lobesia botrana. We see here the adult in sticky paper, and we see here the dispenser, gummy dispenser too. We see again the mechanism of pheromones. Pheromones are released on the air from sexual glands of female individuals. Pheromones are captured from antennae of the male. After that, the male follows the female trace with the pheromone clouds, and the male find the biological partner, the female, and so the mating is realized. This is the mechanism of how two male females meet each other. This is the mechanism. Here is another scheme for illustrations of mechanism on confusion between the male and female adults. The dispenser and female release the pheromone, but in this cloud of pheromones, distribute everywhere in a vineyard, male of Lobesia botrana is not be able to find the biologic partner. It is confused and don't reach the female for mating. Our goal is just this. In this picture we see the female of Lobesia botrana. It has released the pheromone substances, but at the same time we have dispenser here. They have released the artificial or synthetic pheromones in the vineyard. Everywhere here has a cloud with pheromone substances. In these conditions, the male is not be able to find a biologic partner, and confusion is realized. This is our goal too. What are the plant protection products allowed in organic grape production? There are a big number of plant protection products allowed in organic grape production, but the most useful are bioinsecticides with Bacillus thuringiensis bases. There are some Bacillus strains bases. In organic grape, production has found a best solution by using of confusion pheromones. Confusion pheromones create a confusion in mating between male and female of Lobesia botrana, as we mentioned above. They don't find each other, and so is avoid the mating. Organic substances of pheromones are produced in synthetic way in dispenser form. The active ingredient is fixed in gummy small bottle stopper in the case for monitoring, or in the form spaghetti thread in the case of dispenser for control of Lobesia botrana. One from commercial product is Isonet. Here you see the formula of product Isonet that is used in Lobesia control in vineyards. Here is another picture of the structure of confusion pheromone Isonet. On the picture we see the dispenser formulation of Isonet. You see, this is the form. Hanging of dispenser of confusion pheromones in the vineyard is Isonet product. This is the scheme of hanging of dispenser in the vineyard. In the row of grape, a dispenser is hanged in each about 6 to 7 meters. One row between is without dispenser. So, a dispenser could protect about 30 quadrat meter of vineyard. During the operation of dispenser in the grape is formed a cloud of pheromone. On the side of a parcels, dispenser are hanged something more in the number. The density is a little bit more in comparison with the middle of the parcels, in order to blocking the entrance of moths from neighbors' parcels or from another host plants of Lobesia botrana. In this picture we see the isolation distances between treated and untreated vineyards with confusion pheromones for Lobesia botrana control. Untreated vineyard must be more than 100 meters away from treated block, because the fertile female moths came from untreated vineyard to treated vineyard with pheromones, leave the eggs on the berries of the grape, because these fertile females have no need from mating, and they lay direct the eggs on the berries. Perhaps it's important to take into account this kind of distance. Product Isonet is used 500 dispenser per hectare in vineyard. Isonet protect the grape all the season. In general, have no need for another additional treatment with another bioinsecticide. In every case, field analyses are useful in order to be sure for situation of infection from the larvae. In 1 hectare of vineyard, analyzed 100 grape bunches or clusters. If the infection in the grape destined for wine production, economic threshold is about 10% of infected clusters. Something else need to take into account. It is necessary information about another host plants of Lobesia botrana around the vineyard. The host plants could be a source for infection of the grape. Some host plants from Lobesia botrana we can see in table below. Some of Lobesia botrana host plants. Latin name of the plants, English name of the plants. Vitis vinifera, grape wine. Berberis vulgaris European barberry. Iribis nigrum, black currant. Prunus spinosa, blackthorn. Rubus fructicosus, blackberry. Ligustrum vulgare, common privet. Vitis aestivalis, wild vine. And Hederasilix evi. That are some of host plants that we need to take into account to control around our vineyard. Has such kind of plants or no? And if we have around our block some of such plants, we need to hang a little bit more dispenser around our vineyard in order to block the potential female to came in our vineyards. Another alternative for Lobesia botrana control are the bioinsecticides with the basis Bacillus. There are many strains of Bacillus. The successful of the grape moth control are Bacillus thuringiensis berliner and Bacillus thuringiensis courstaki. In the market, there are a big number of formulations and trade names with Bacillus base. If are using bioinsecticides with Bacillus bases, need to take into account some conditions. It is necessary to emphasize that Bacillus has effect only to first and second instar larvae. For that reason, need monitoring flying curve of Lobesia botrana adult and monitoring of level of infection of larvae berries from the larvae. If the treatment are made late, the result will be not so good. The treatment need to repeat within the 10 days. The treatments need to make during the fresh weather, during the late hours of the days, because the sunrise caused the damage of bacteria. The treatment's quality must be focused in uniformity of liquid distribution on the green part of the berries. On the other hand, it's recommended if liquid to add some sugar because he increase the efficacy of bioproduct. Positive economical and ecological impact of organic grape production. In organic grape production, beneficial fauna is more rich than in conventional grape production. Beneficial insects play a positive role in reduction of Lobesia botrana population in vineyards. In organic grape production, as a result of rich beneficial fauna, almost we don't have the presence so-called the secondary insect pests, as spider mite, scale, cicada, thrips, etc. If we use the confusion pheromones, infection is so small, 1 to 3%. We have no need to treat against gray mold diseases, Botrytis cinerea. Avoiding conventional insecticides protect the environment from chemical residue too. If we speak about the cost difference between confusion method and conventional method, we could say pheromone cost is higher than conventional insecticide, but is much more cheaper the implementation in the vineyard. Only 3 hours per hectare need to hang the dispenser in vineyard, nothing more. Conventional insecticides are more cheaper than confusion pheromones or mating disruption pheromones, but it's much more expensive the treatments with different spraying techniques. In Albania conditions, the cost of 2 methods are more or less the same. If we take into account the advantages of ecological impact, the method of Lobesia botrana control with confusion pheromone is more cheaper than control with conventional insecticide. It will be a very good interest if the government of each country subsidize this ecological control method of Lobesia botrana in vineyard. The using of confusion pheromones against Lobesia botrana are the future control measure and economical advantages. This was the last slide of our presentation for today. I make a summarize. Today we have discussed about selection of the place from vineyards, selection of the soil, selection of right cultivars. We have discussed about plant nutrition, plant protection, and we are focused especially in Lobesia botrana control with confusion method as a modern control measure with a positive impact in environment and in economic point of view. Thank you very much for your attention for today, and goodbye to the next lessons.